so first thing I want to talk about is polyatomics. Okay, so we've talked about several different polyatomics, and I've given you just a whole bunch of polyatomics, but we really haven't talked about the rationale behind their names or anything like that. So let's look at one real quick. Nitrate. Okay, so all polyatomics are made up of two things. Well, most are. They're made up of a prefix and a suffix. So in this case, we have nitra, and then we have 8. So what is nitrate? What's its compound? It's not NO2. It's what, Austin? NO3. So nitrate is NO3. Okay, so our name, we have nitra, which refers to the nitrogen, and then we have the 8 that refers to the oxygens. And so we also have another polyatomic that's very similar, which is nitrite. Right? So again, we have the same nitra at the beginning, but now we have ite, I-T-E. So does anybody have written down what the compound for nitrite is? Yeah, it's NO2. Okay, so based on just this, we have nitrate, which is NO3. We have nitrite, which is NO2. So what can we say about this ite, I-T-E? What does that mean? Not necessarily 2, but it means 1 less oxygen. That makes sense? So we can say blank ite refers to 1 less oxygen. Make sense? Yeah. Great. So we also have another thing we can write. I'm going to write hyponitrite. So now again, we still have the same nitra, and we still have the same ite, but now we have hypo. What do you guys think the hypo refers to? Not quite water. It still refers to the oxygens, but when we have hypo in front, it actually means 1 more or less. So hyponitrate is actually going to be NO. So we can say hypo blank ite is going to be 2 less. Make sense? Yeah, it always refers to the oxygen. Okay, so then we have one more. We have pernitrate. Okay, so notice we still have the nitra, but now we're back to 8, which is what we started with. And we have a per in the front. And we want to guess what pernitrate refers to? 1 more. Yeah, it refers to 1 more oxygen. So this is actually going to be NO4. So per blank 8, 1 more. So for the most part, most of our polyatomics, just the 8 by itself refers to 3 oxygens. So we have a bunch of different ones. We have nitrate, we have chlorate, we have sulfate is actually a little bit different. What is sulfate? Sulfur. It's sulfur, but how many oxygens? 4. Yeah. Sulfate is kind of the one exception. Sulfate is SO4. The rest of them, the 8 refers to 3 oxygens. Sulfate, and I'm sure there's some others out there that have the same exception, but for the most part that we'll be working with, sulfate is the only one that has 4 oxygens. The rest of them are 3. But the same thing applies to sulfate. So if we do SO3, what is that going to be called? sulfite. And then we can do hyposulfite, which is going to be what? SO2. Make sense? All right, so then the one last thing, in these polyatomics with all these suffixes and such, how do you think this affects the charge of the polyatomics? So we know, what's the charge of nitrate? -1 or 2? -1. Okay. Oops, I'll put it on the over here. Okay. The number of oxygens, actually, I know it sounds kind of odd, but it actually doesn't affect the charge. And so all these are going to be the same charge. -1, -1, -1. So they're all -1s. Same thing with the sulfate. What's sulfate's charge? -2. So sulfate is -2, so sulfite is going to be -2, hyposulfite is going to be -2, and so on and so forth. Make sense? Any questions? Yes?
So what did you say with the charge of the thing other than the oxygen?
What do you mean?
Like sulfur? Is sulfur's charge -2?
No, the polyatomic as a whole is -2. Okay, so those are our polyatomics, and so I don't expect you to remember all the polyatomics, but I do expect you to remember these suffixes and prefixes. So if I give you like nitrate, and then on your test you see nitrite, I do expect you to know what that is. Does that make sense? So I'll give you like the nitrate, sulfate, carbonate, all those kinds, and then vary it up depending on the suffixes and stuff. Okay, so the next thing that I want to talk about is naming acids. Okay, so we're going to name acids. There are two different types of acids that we're going to name. There's acids that have oxygen, and then there's acids that don't have oxygen. So the easier of the two is acids without oxygen. Great. So if it's an acid without oxygen, well, before we even do that, to identify an acid, whether something is an acid or not, there's one big dead giveaway of if it's an acid. And that's that all acids start with hydrogen. So it's always H and then something else. It's not always, because we have H2O, which obviously isn't an acid. But for the most part, yeah. Okay, so all acids start with H. And so if it's an acid without oxygen, it's just going to be the H and then one other element. And so to give you an example, we could have HCl, we could have HF, we could have HBr, so on and so forth. And so to name them, we just we add hydro to the beginning, blank, and then ic at the end. So what do you think we're going to go in the middle? The other element. Yeah. So HCl, what is that going to be? Hydrochloric acid. What about HF? Hydrofluoric. And then the last one, Br? Hydrobromic. Awesome. Okay, so those are our acids without oxygens. Make sense? Easy? Okay, so if it does have an oxygen, it's going to have an oxygen followed by a polyatomic. So the nitrates, nitrites, all that kind of stuff. And so there's 4 kind of, with the prefixes that we just talked about for polyatomics, they apply directly to the acids as well. Okay, so if we start at the top with the most oxygens, our polyatomics with the most oxygen are per blank 8. So if our polyatomic is per blank 8, then our acid becomes per blank ic. Huh? If it has oxygen, we follow these. So then 1 less oxygen than that is just going to be 8. So our acid becomes blank ic acid. And then 1 less from that is going to be ite. So it'll be blank ite acid. And then 1 less from that is hypo ite. Oh, I'm sorry. That's wrong. The ite, we don't carry over the ite. We change it to OUS. Sorry about that. So just our blank ite becomes blank OUS, and then hypo ite becomes hypo OUS. Okay, so let's look at a couple of examples. If we have H2SO4, what is our polyatomic? Sulfate. So our polyatomic is sulfate. So if we look at our list, that falls in right here. And so we can scroll over. And so all we do is replace the 8 with ic. So what's our acid going to be? Sulfic acid. No. You only write hydro if it doesn't have oxygen. Okay, so it becomes sulfuric acid. Okay, let's look at the next one, HClO. What is our polyatomic? Yeah, it's the chlorine and oxygen. We know chlorate is going to be ClO3. So what is ClO going to be? It's not going to be chlorite. Chlorite would be ClO2. Hypochlorite. So our polyatomic is hypochlorite, which is this one right here. Oops. So our polyatomic is hypochlorite, so we scroll over, and our acid becomes hypochlorous acid. Make sense? Okay, so take a second, look at the last one. Come up with an answer. Oh, so, well, we know that based on what we just talked about, we know NO3 is nitrate, right? So NO2, one less oxygen from that is going to be what? Nitrite. So if we look back up at our table, nitrite, ITE is right here. So it becomes nitrous. The compound just doesn't, like, it's something like this. Make sense? Okay. Yeah, just nitrous acid. Okay. Any questions with that? No? Okay, so one last thing that I want to go over today is covalent bonds. Covalent bonds are really, really easy, and that they're bonds between two nonmetals. And so when we're coming up with a name, first thing we do is write first element. Second thing we do is we write second element. But just like before with the ionic bonds, we change the ending to IDE. So we change the end of the second element to IDE. So we get the oxide, iodide, fluoride, all that kind of stuff. And the third step is we use prefixes to indicate, to state okay, so we use prefixes to state how many atoms of each element we have. So I'm just going to write out all the prefixes. All right, so those are all of our prefixes that we use to identify the number of atoms present. And so naming these is really, really easy. Yes? Yes. Okay, and then the last little thing is no prefix is needed for the first element if there is only one. So we don't put a prefix on the first element if there's only one of them. Okay, so let's look at a couple of examples. CO2, we write out our elements. So we have carbon and oxygen. But what do we change the end of oxygen to? Ide. So it becomes oxide. And then we put in prefixes. Do we need a prefix on carbon? No, we don't put a prefix on carbon because there's only one. And then what is our prefix for oxygen going to be? Di. So it becomes carbon dioxide, which everybody knows what carbon dioxide is, right? You're filling the environment with it as we speak. Okay. All right. So what is N2O? Write out our elements. Oops. Nitrogen. And again, it becomes oxide. And so what are we going to use for a prefix in front of nitrogen? Di. And then do we need a prefix for oxygen? What? Yeah. N. Mono. So it becomes dinitrogen monoxide.
Does the prefix have to be capital?
I don't think so, no. Probably not, no.
And would you capitalize after the prefix, or would you still capitalize?
No, you don't have to capitalize the first letter of the element. I just did that for emphasis. Okay,